A to F is basically 10 to 15. So basically what we have to do now is we have to find the binary of 10, 6, 3, and 12, and then apply one's complement, like to make it to flip the number, because it's we're getting it as a positive, so we got to make it negative. So everything has to be flipped.
The way I like to do it fast, um, just remember that 8 is like 1000. So this is 1, 2, 4, 8, and then 9, and then A, B, C. 1, 1,
Yeah, let's work
2.
it out long form for people that aren't here.
Oh,
Yeah, let's like go in order of how to do it, like
Yeah,
in
because
detail for
people,
people that don't know it.
because there's gonna be a lot of people who are gonna watch this. They're gonna be like, "How do I do this?"
yeah. So the way I do it like kind of fast. So the 1 is like 0, 0, 0, 1,
Mhm.
2, 0, 0, 1, 0, 3, 0, 0, 1, 1, 4, 0, 1, 0, 0. So the way I do it kind of fast is I just add this number to the displacement of these numbers. So 8, the letter A, the number 8, add that 2. So this is going to be 1, 0, 1, 1, 0. So this is just like a shortcut. So you just add this number to these numbers over here. So you will obtain this number. It feels weird to call this a number, but this letter B is a number. That's what they're called. The number B over here would be 1. This one up here, 1, 0, 1, 1, and then 1, 1, 0, 0. All right. So A6 would be that number 8 would be 1, 0, 1, 0, and then number 6 would be 4 plus 5, 6 plus 2, which is this over here. Is this 0, 1, 1, 0. 3C, number 3 is over here. 0, 0, 1, 1. C is over here. 1, 1, 0, 0.
0, 0. Yep. So we got that part down. Now we just gotta, because they're all negative, what we have to do is we have to go ahead and flip every single number.
Uh-huh. Get this. Okay, so this is 36, this is 3C. So to get a negative, let's use one's complement.
Yep. One's complement, and you're just gonna flip all the numbers. So you know how A we have 10, 10. It's gonna be instead of 1, 0, 1, 0, it's gonna be 0, 1, 0, 1. And
Yeah.
then 6 is the same way, and that's how you do it.
One, 0, 0, 1, 1, 1, 0, 0, 0, 0, 1. So the way I like to do it, I add one extra 0 over here to remind me the sign of the number. So this is a positive number. So when we flip everything, this would become a 1 over here. So this reminds me that this is a negative number, a representation of a negative number. This is negative A6 and this is negative 30C. Right. So we need to add those numbers, right? Was that what he asked?
Yeah, we need to add them together, I believe. Wait, so once complement, how many digits, or for complement, we use 8 digits total, right? Or 8 bits?
Yes, 8 bits.
Oh, shoot. So we broke it down by 4s. That means we got to add a bunch more.
What do you?
So like, how 10 is like 10, 10. That means we got to add like 4 zeros before it.
Oh, I don't think you have it because you can do addition to any size of the numbers, but I don't know if he's gonna ask for the 8 bits.
I mean, I guess because when I think of one's complement and two's complements, we always use 8 bits.
Mhm.
I think we should use 8 bits just in case. Just in case, I think that's probably the best way to do it.
Yeah, so
Yeah,
I think the question in class was, would it be in 8 bits? And he said maybe.
What do you mean maybe? Yes.
So I would do 8 bits because that's been the standard for the entire course as of yet. So definitely do 8 just in case.
Yes, the standard.
we just add this one. Is that what he asked, or do we make him like an adder?
I think we're making an adder for the, I would assume, the result. Or is it for, crap, how did he word it? Because I don't have the entire question. I just have the beginning work for it.
So let's just finish the result for this one. So we
Yeah.
just add this one here. So when you are doing addition binary, it's not exactly addition. You are making you're compiling these numbers together. The notion of addition becomes like plastic. So you're just smashing this. You're pressing one number against another when you're doing binary addition, because computers, they cannot do like subtraction. They cannot pull things apart. They can only put things together. So over here, 1 becomes 10. You guys know how to do this, right? 10, 1,
Yeah.
10, 10, 1, 1, 1, 0, 10, 10, 1, 1, 10, 1, 1, 1, 11. So we have one carry over here. Oops. We have one carry over here. This carry must be added back over here. And then we add it again since we are doing one's complement. So this becomes 1, 0, 1, 1, 1, 0, 0, 0, 1. All right. So this tells me we have over here, and we have one extra number. So this tells us that this number is negative. And then to figure out what this number is, the result, the magnitude of the number, you need to flip everything again. So it'd be 0, 1, 0, 0, 0, 1, 1, 1. This is the magnitude of the number. So this number over here becomes a 0 again, like was originally over here, up here. It was 0, so it becomes a 0 again. So this number is these two numbers together. So let's see what number this is. So here's the function. Let's see if I can do like we did in class. 1, 2, 3, 4, 5, 6, 7, 8. So we have 1, 2, 4, 8, 6, 2. Okay, so 0, 1, 0, 0, 0, 1, 0, 1, 1. So this number becomes 128 plus 64 plus 32 plus 2. This number is 226. Now let's have an hexadecimal calculator.
Oh, we can't use it. Actually, yes, we can. I just realized we can use it since the exam is not in person.
So negative, was it negative A6? A6 plus negative 3C. Okay. Negative 2 to 6. There we go. That's the answer. negative E2.
So what if you add four? Is it like, you know how we when we first convert it to a decimal? Like what if we add like four decimals before each one? Oh, I'm sorry, 4 zeros before each one. Like you know how like in the beginning 10 used to be 10 10. What if instead of 10 10 it was like 4 zeros then 10 10, and then we flip that to like 4 1s and then 0 1 0 1, and we did the same for all of them? Would that also work? Because usually with one's complement, we kind of have to put 4 zeros before whatever we have because it's 8 bits.
So the reason you can do that, but the problem is that often this last number over here is used with the meaning of being negative. So when you add a lot of other numbers, that could get confused. But still, I believe you can do that. Like let's see what it means doing like this 0 0 0 0 1 0 0.
Yeah, and then go from there. Because that's how we usually do one's complement and two's complement. Because he always stresses 8 bits, right? Like,
Mhm.
so he always says add zeros in the front to make it 8.
Yeah, it would be something like this, right?
But I mean, I did it on paper. It's like really long.
Uh-huh. Well, you can do it. It doesn't change the result. You just have to remember that when you're going back to this over here, this is the magnitude and not the other numbers that it doesn't make a difference because let's say this number here was the result, right?
Mhm.
This number actually has like this many ones after it. And when we flip it back to this number, all those numbers become zeros. So they don't make a difference. So yeah, you can do that. So this is just extra work, I believe, but you can definitely do that.
Okay.
So what was the other thing that he said about this?
We had to design an adder at a gate level from this.
Okay, an adder at gate level. So this is, okay, so to compute this number, we need to have 1, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness.
Yeah, it was a really big one.
I hope he doesn't put this on the exam. I really hope.
I'm praying.
Like this is just like
You know how to
this
do
is,
this.
this is the worst curveball of all curveballs that he could throw.
So, you guys know how to do this, right?
I know how to do an adder design. Yeah, just at the gate
Yeah.
level.
Yes. So the adder,
Do a CN and then do an OR gate as S0, and then you go down, you have an AND, you have like two AND gates. To the left, you have A0 and B0.
I think you can draw on the screen. Try to draw it. Can you draw it? Can you try to draw this one?
I
I
think
don't
he
know.
would
Can you
have to
draw?
share his own.
I'm okay. Like this. Can you see it?
Yeah, I can see that.
Yeah, we can
yeah.
see that.
So how are we gonna draw for the exam exactly?
For the
Like, are we?
exam, he said that we can put on paper and then send it.
In the picture?
Yeah, so you'd probably take a picture and put it in a Word document, or you'd take a picture, scan it, and then put it into a PDF.
Okay.
Really, any of those. It depends on, because when you get into the exam, it's probably going to have submission types that you can put onto it. You would just use those submission types.
Okay.
Yeah, definitely use those like the last 15 minutes if you could spare them. Use that strictly, like the 10 minutes strictly for getting your submission in, because there's always weird upload, download speeds on top of trying to format all the files for that, because you don't want to run out of time if you wait till like the last 5 minutes to do that,
Yeah.
just in case
This
something
would be
goes
so
wrong.
much easier if it was in person.
Yeah, it really would be.
I'll draw the adder over here. And you see if that's the same thing that you have over there, okay?
Okay.
So since we have like 8 bits, eight spaces to add, we will have like this structure over here. So we have A1 and A2. So they both go into an exclusive OR gate. Let's see here. That's called your exclusive OR gate. And then these two inputs will come into an AND gate.
Yep.
Then this AND gate comes into an OR gate. And then this structure over here repeats more 8 times. So
Hold on, don't we have to make like a CN and then like
yes, that's just for you to get a general
Yeah.
idea to how to build the entire thing.
So I
And
would say like to do at least 2 or 3 adders, just like they get the idea of it, and then just put like ×5, ×5, ×6 to like get the idea across it. Like, yeah, you're doing this many of them. It's crazy. That's a lot of numbers.
unbelievable.
yes. This
Let me
over
post my work to the Discord real quick
Oh yeah, we can do that as well.
because I want to see if I did something. Someone needs to correct me.
So this over here, this entire thing over here. This
I
entire,
would put it to study group if you're gonna send it to the Discord.
No one reads it though, so I'll put it in the general.
why you can't select my pen? Okay. Okay, so this, you see this entire thing over here?
Yeah, I see it.
So this entire thing is just these 2 numbers over here. So you do this again for as many numbers you have here. Does that make sense?
Uh, I was hoping more people could give their input.
Was the point? Hello.
Yeah.
Was the pun intended?
Oh no, I was typing back in the Discord, and I missed the question.
Hey, do me a favor, Dimitri.
Yeah.
Look in the Discord real quick. In the general, that's my work. You know how I told you I put the 4 zeros before to make it like an 8-bit? Could you do me a favor and take a look at it real quick?
Okay, so each number you translate it into the binary and place 1, 3 zeros, and then you click, oh, and then you add it.
Isn't that how we usually do once complement? We like flip it if it's negative and then we add it together.
No, you can't do that. You can add different number.
It's too big of a number, right?
Yeah, you change. So it's like doing this. So can you see this? You see the screen, right?
Yeah, I can see it.
So 12 plus 13. What you did was something like this. 1, 0 plus 1, 0 plus 2, 0, 3, 0. And then you flipped, let's say, and this became 10, 10, and this became just as an example, 2, 0, 3, 0, and then you put together these numbers again, and then they became 1020,
Yeah, it's huge. I noticed that.
1020 plus.
So 10 and 6, they're supposed to be, um, they're not
We-
supposed to be separate then?
You see that these two numbers over here, they're different.
Yeah, because it's 1 and 2 as opposed to 12 and 13.
Yes, exactly. So
So,
yeah, you can do that. You can do this 12,0,0,0,0 plus 13,0,0,0,0. So you can do this. You can do this. Okay.
okay.
It's the same thing binary. So if you have 1010, you can do 0,0,0,0,0. You can do this. The same thing. But
Okay.
if you do like, if you try to split this like 10, 10, and then put zeros over here, you will obtain a different number. This is a different number.
Okay.
Make sense?
Okay. So instead of, so like, how would I put like 10 and 6 together then?
10, 6 together.
Like, you know how I, like,
Oh, I
how
know
we
what
got,
he's
like-
asking. So for his thing, you have to go straight from hex into binary and then add your leading zeros. You can't add your leading zeros when you're converting from hex to decimal because hexadecimal is shorthand hexadecimal is shorthand binary. So you
So it should
adding
be-
you adding zeros before each individual. So if you put A, you put it in you put it in binary, and then you flip A, and then you flip 6 before you put them together, you're going to get a different value because you can only flip it once they're already together.
So I gotta put A and 6 together first.
Yes, and then you can add your leading zeros.
Oh, let me do it again.
Yeah, here, I can show the example on the recording for people to see it.
That's
It's
what
right
I'm
here.
wondering.
Because right here, he added the leading zeros onto A, onto 6, and you'd have to add them both together and then put your leading zeros if you want them. That's what we're meaning by that. Because I
Okay.
didn't have it on the screen for the recording. Yeah, does that make sense? I understand
That
where
makes
you...
more sense.
Yeah. Yeah, because I'm like, oh, I see what he's talking about.
Because we never had like 10 and 6 together. We always had like, you know, negative 15 minus 12 or something.
Right, he never did
It was more
hexadecimal or octal. You have to watch out for octal, so you have to see what he gives you for your input, turn it into binary first, and then once your entire numbers together in binary, that's when you can add your leading zeros and flip. You don't
This
want to
one's
add
not
them
so
before.
straightforward.
Yeah, he should have probably clarified that in case it did mess up people, but yeah.
Yeah, he doesn't care.
That's where the mistake was.
I mean, it's the truth. He doesn't. Okay. Let me redo this.
Do you know what else he asked about this question?
Yeah, the only other thing that he said was to make an adder out of it. And then once we have the 8-bit adder, then that's it.
Okay, so then we repeat this structure over here like 10 times. 8 times.
Yeah, we'd have to have 8 of them. I don't know if you'd want to write out all 8. I would at least do like 3.
Let me see if I can
But-
do this.
Wait, so I put 10 and 6 together first, like 10, 10, and then 0, 1, 0, and then 0, 1, 1, 0. Put that together and then flip, right?
Yeah, so for A6, it would look like, sorry, let me find it. It would look like 1, 0, 1, 0, 0, 1, 1, 0, and then you'd flip that entire thing together, then put your leading zeros.
Okay, that makes more sense.
Yeah.
So it doesn't become like a massive number.
Yeah, no. Yeah, because taking 10 and 6, those would be entirely different numbers at that point.
Okay,
If
makes
you added the
sense.
zeros to them.
With the aid of technology,
We have technology.
we have an 8 adder.
Oh my god.
Unbelievable.
This goes, so this little thing over here goes this big over here. So this is the output. Let me get this.
Oh, that's the half adder.
Yes.
How come you didn't draw the full one? We don't need a full one for this one?
No, he still has to draw it, I think.
Oh, okay. I'm about to say, is Montagne asking us to draw half adders now?
No, we have to do the full adder.
Yeah, there's no way.
I'm just connecting everything. Hold on.
Oh,
And
okay. I mean, the full adder is basically like
I
half
wonder
adder
if you
times
should have
two.
drawn the entire adder and then did that, because this might be a
Yeah,
little
it probably would have been
difficult.
smarter.
Oh, you can zoom in. Okay, we're good. Never mind.
then this goes over here, and then this over here, and then this same thing over here, over here, and then there's the next door over here. And then there's an and gate over here.
Wait, so before I make so with A6, before making a negative, I can add the 4 zeros in the front first, right?
Yes.
But would it be necessary to add the 4 zeros in the front to make it an 8-bit, or because it's already 8, like it's already 8, it's already 8. I don't think I need to do that.
So you can add, let's say you have this number is different from positive A6 in binary.
Mhm.
So this, let's say, how much was it? Oh, it's over here. This is 0, 1. No, it's not. This 1, 0. I think this is flipped. Hold on. This is flipped. This is 0, 1. 0, 1, 0, 1. 1, 0, 0, 1. So this number is this over here, and this number is 0, 0, 1, 0, 1, 1, 0, 0, 1. So this is this thing over here. Do you see?
Mhm.
That's the difference. When you
Okay.
this thing into negative A6, you have to flip this entire thing. And this entire thing flips. This becomes a 1, and then 1, 0, 1, 0, 0, 1, 1, 0. Now this is a negative number, red for negative number. So this is the magnitude of the number, and then this tells you that it's negative, but it's not the same thing. So you can add the leading zeros to remind you that there's a negative as the sign. You could do the same thing like this. I'm sure you could do the same thing like this. 0, 1, 0, 1, 1, 0, 1. And then you could add like 0, 0, 0, 0. And this entire thing is the sign. And then when you flip, it becomes 1, 1, 1, 1.
To remind you that it's negative, yeah.
1, 10, 10, 0, 1, 1, 0. So this entire thing over here is this negative. So you can do that.
Okay, I see that.
I'd probably only add on if you really have to.
Yeah, I just add only one extra space.
Yeah, normally.
You don't have to add the entire thing.
So would the answer be 0, 0, 0, 1, 1, 1, 0, 1?
Or for what? For the A6.
So like, yeah, A6, negative A6 minus 3C, would it be 0, 0, 0, 1, 1, 1, 0, 1?
Try do have, let's see, try to convert that to binary or to decimal, to hexadecimal or to decimal.
The decimal. Dang it, I gotta do all this. Okay.
Yeah, to confirm, you'd have to take the hex that we were given, turn that into binary, then turn that into decimal. So you could find the answer to confirm it. In the case of practice, I guess you could use the calculator, but on the test, no.
No, I got it. Like I'm way off. Like 29. What the heck?
You said 29.
Unbelievable. Yeah, like I'm way off. What the heck?
Can you show your paper?
Let me just send this
Yeah.
to Discord because right now I'm not in a good shape. This last question made me realize I'm not in good shape.
It's just some, like, stuff that you forgot. It's not that bad. This is why we do reviews.
I didn't forget anything. This was just a curveball.
Oh, yeah, no, this is a really big one for him to give us and then not finish it in class.
Yeah, like he could have showed this to us like literally last week.
Yeah, I can't even fit all this onto my paper. I'm gonna try to draw 3 at least.
Oh boy. Okay, look.
Ladies and gentlemen, I present to you a full adder of an 8-bit number.
That's a full adder of an 8-bit number.
Oh my
Yeah, draw
god.
like 8 full adders. Unbelievable.
So,
I love how big the exclusive OR gates are.
yes.
You know what? That's 10 points off.
That's
10 points off.
They're not perfectly pointed at the end. It is 10 points off your exam.
No, he that might happen.
Probably. That's what I was saying. It if you really want to make sure, just put XOR where that gate is at. Because then at that point, that's kind of mean that he's marking you off because you tried to show the difference and then you also wrote what gate it was. So